Welcome to another teardown video. This time it's a 2-channel AC millivoltmeter. Look at this. From the company called Leader. This one is called LMV-89. I really can't find anything online about its specifications. I can find other models, but I can't find this particular model. Not even on the Leader webpage. This company still exists today. As far as I can see, this one covers 110 dB range from 300 volts RMS, that is plus 50 dB, relative to 1 volt. So this is dB volts. And of course we can go the other way, down to 1 millivolt. So that is minus 60 dB volt. Right? So that is the coverage. The display covers about 20 dB in one go. Is there a little bit? I really always wanted to tear down one of those, because you got 2 indicators here, right? Inside here. So how the heck is that done? I never took apart a dual meter. Okay, so that is, they do move. No, they don't. One is stuck. So the problem is something to do with the meter. This is something that happened before I was shaking it. It didn't happen. So we have 2 0 trimmers for mechanical 0 of the display. And you can select between each readout is each channel, or you can add them. So I guess this is adding. Could have been cool with subtracting as well, huh? So I guess this is the on-off switch. It's really hard to read the red anymore. Maybe it got a little bit more too much sun, because this tends to dim the red ink. And I guess this is the power on indicator. All the way around this meter I find trimmers, so you can access trimming or adjustments of this unit from the outside. So here in the bottom I see trimmer capacitors. 3 of them in the bottom. Ooh, somebody dropped this one. That is one nasty. And on the other side I find 3. On the back side we got some output. Doesn't say exactly what kind of output that is, but I guess this will be amplified output from each channel in, I don't know, whatever normalized range, so you can put something external. Look how nice this cable is mounted here. How cute is that? I don't see any indications about how old this is. Maybe I can write Leader company and ask for information. That could be cool. So what should we do? Should we tear it down first or power it up? See how much smoke there is in this box? Maybe we should do that first, right? Right? Yeah, we're gonna do that. See what happens. Before we power this up, I want to show you this trick with analog meters. Look what happens here when I touch the trimmer. And then it goes. It's affecting the other one. Right? Let's try the other one. And then what happens if I do like this? See? Now it's a completely different result. And now it's not affecting the other one. Now I can trim it for 0. So you cannot touch the plastic. See? Now they're not affecting each other. It was static charge on the plastic. So never touch the display. So now we got a perfect 0. Now we can power it up. So, of course I promised always to start the video when I'm powering up stuff, because you never know what's gonna happen. Okay, no electric shock as far as that. And the switch is off, good. Ooh, that can't be good. Why is it doing that? So this is only 2.7 watts. Oh, there's a blinky, a neon bulb. But I got full. Okay. So this one is the red one. So there's definitely. Ooh, it is sensitive. So the input. Oi. Look at that. Let's go to 1 volt. Just touching the. So that means this one is maybe in. Yes, that was the problem. And the other one. Oh, look at that. This thing is alive. It actually looks like it's working. Hey, let's get some cables and a signal generator and see if this thing actually works. Maybe I can find a button for this one, and so I can. Yeah, I'll be back. Wow, I'm actually a little bit amazed. So this is 1 volt, 1 volt. Look at this really nice cable here. So what I've done is, I think this is 1 volt, right? And I think this is 1 volt RMS. I set this for 50 ohm, and this is 50 ohm. So that means this is just to control the impedance in the signal. So that means if I turn on and off the output, it's gonna be loaded with the 50 ohm. So that is 100. No, that was 1 volt. 900. 8. 7. 6. 5. Look, the gain is a little bit too low. 4. 3. 2. Of course, it continues. And then this is 100. So, yeah, there's a little bit of a gain, and also a little bit of gain difference from one channel to another. And I don't know if that can be fixed. So that must be some sort of a gain thing. But other than that, this is really amazing. It is that accurate. How old is this unit? I expect it to be quite old. Now we're gonna go and open it and see if we can find anything with an age indication. So this is real easy. Just unscrew, and then the whole cabinet can be pulled out like that. Super easy. How do you think that is? A nut? Yeah. This is how you do it. I love it. It's just fantastic. There's a special smell in this one. Wow, that switch is definitely switching a million things around. Wow, look at that. This is the 2 position. Holy cannoli. So this is the input that goes up here, and then you can swap one way or the other way. And then, oh, we got also a little trimmer in here. That is fantastic. Look how the wires, they just go around like this. And a little bit of capacitor compensation. Ah, this is so the wires don't get stuck when you open and close the lid. So that is the trick. So this is the PCB. Okay, yeah, of course there will be two identical PCBs. Oh, those are really nice and soft. Okay, so this PCB is used in the LMV-89, 88, 89 and the T160G. Oh, look at those details. Collector, emitter and base. So we have indication on the transistors, and again here. Ooh, what is that? Gate drain source, so there will be a field effect transistor here. Fantastic. Let's see if we can... Ooh, this is the thing. So it was recapped in 17. Oy, 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 oy. I actually called and heard about the age of this unit, and as far as they could tell, this one was bought in 1970 or 1975 or in between. So this is 50 to 45 years old. Oh, that is some fancy looking transistors. And look at those down there. Aren't they just cute? This is the meter. Oh, some additional capacitors over the meters to slow them down. So this is really good, because when you move them, when you move this the whole unit, the meter just go flippity flop. And this you can help by adding capacitors here, but also they will add a little bit of leak. And that could also be a reason for this to be bad. Oh, we got two wires on the meter. Just can't wait to figure out how they made the meter work. I guess there will be a power supply somewhere. Is it in this one? So that means there's a tiny little transformator in here. And you can unscrew this. I definitely want to go in there. So mains is here and two wires. Ooh, did I unplug? Now I did. Don't touch anything. Oh, so you can move this. Oh, this is maybe because you can make it 110. So we've got two different wires. But I don't see any documentation in here, and obviously there's no manual. I can't even find this model here on the internet. So I expect there will be a transformator or something, and then we have the output here. So those outputs, they go... Where the heck are we going? And I don't see any rectifiers or regulators or something. So that means we will have everything in this little box. Okay, it goes here. Okay, so the neon indicator is connected directly to the power supply, and the on-off switch is also connected to the power supply. Oh, what is that? The power supply also got wires. Oh, now I know what they're doing. So the power switch, when the power switch is in off, it's short circuit the meters. See that? That is exactly what they do with those wires. This is the short circuit. Yeah, that is actually pretty smart. And this is mains voltage directly up close. Let's see if we can see this from the other side. Oh yeah. So that will be the 2 meters short circuiting, and this is mains that we turn on. And we actually turn it on by flipping it up, and then we short those 2 wires. So this will be in a shielded cable. But okay, here, I found it. Those are the wires from the transformator. Aha! So this is the bridge rectifier. Yeah, look at that. This is AC and 2 diodes in one package and 2 diodes in the other package going the other way. So this is a bridge and a capacitor and some other goodies. Okay, so those 2 PCBs, they are... Oh, look at that. Yes, this is exactly mirrored. So the design is mirrored in one end and the other end. One channel is a mirror image of the other one. How cool is that? So they needed to figure out how to relay out everything in a mirrored version, so it's not the same PCB. No, let's make a mirrored version for the other channel. Wow, so this PCB will be called left or right? Somewhere? No, that is not right. The text on one of the PCBs is mirrored. What the heck? Have you ever seen this before? So this is the same film. All they did was turn the film over and then do the other PCB. So the text is mirrored on one channel. Wow, what? That I have never seen before. That is a first time, and I really took apart a lot of electronics. I've never seen this before. Look at that. This is the text and everything, and even the logo, everything here is perfect on this channel. So the left channel is the right one, and the right channel is the mirrored one. That is so funny. Okay, so some indications on here. What is what? This is for recapping. Of course, the boards, they have been all the way out. So this will be indication on, how to put it back on or back together. Wow, that is fantastic. Okay, I want to go in here and have a look. I will be back. I am now in. Of course, there's a transformator, a really nice shielded one. And all the cables, they are of course shielded. Even the mains input cables, they are shielded. I don't know how visible that is, but this is the earth connector, or this pad here is the earth. And all the cables, this is the mains and the 0 input, shielded cables. And then there's a cross over here. I don't know, this is maybe for configuring mains voltage, but there's another output. And this one goes down here, and there's a 100 kilo ohm resistor, and this goes to the neon bulb. That's a little bit odd. So I think this 68 is the year this transformator was manufactured, and this match up with this unit being sold a few years later. Maybe they had it stock for some years. You never know. Look how the output for the external is directly connected to chassis. And again, shielded cables. Let's just try and measure the input capacitors here. Old oil capacitors, they're famous for the insane low leakage. This is really why they use capacitors like this. So this is 50 years old. And I am measuring more than 2 gigaohms. It was reading 1 point, I don't know what, and then after a little while it went over. See, if I just touch, not just touch the both sides here, so little with my fingers, maybe I can discharge the, see if I can do that. Maybe I should just try and swap the plus and minus here, right? No response. That is a little bit odd. Okay. So now I swap the wires and the voltage that it put in has been reversed. So now it is charging the capacitor with the tiny sense current that it's using. And all we have to do is just wait, and it will just go on and on. So this is in low power mode, so it's charging really. So let's go out of low power. Now we'll charge a little bit faster. And then let's have a look. It just continues until the meter goes into overload. That means I can't even measure the leakage in this capacitor. This is going to be a boring video. I think I'm gonna, yeah, okay. So more than 1.2 gigaohms. Fantastic. Oh, I also found out about this switch, by the way. It selects between 2 individual channels. That means the settings is individual. It will always be 2 individual channels, also in this mode. But what it's doing is it's actually copying the settings from channel 1. So channel 1 settings will now be the settings for both channels. Instead of having 2 sets of the very expensive set gain resistors, they actually take the gain resistors and like disconnect them or remove them from this contact set and put the resistors to another contact set over here that is connected to channel 1. Sounds like a very complicated mechanical solution, but this is how it's done, so that both channels can be gain adjusted with only turning around in channel 1. Don't you just like that? So you need a very expensive and complicated switch, but you only have those resistors one time. And I guess those resistors, they will be very expensive and very special. I can see a lot of numbers on them. how many percent tolerance? I really don't know. There's also the input series resistor in here. This is a high value input resistor in parallel with a trimmer capacitor. This is for frequency compensation, so that the very wide range this unit can cover is compensated. If you ever try to take away the meter glass on some of those big old meters, look for this one. The secret screw that will drive you nuts. Okay. This is the trick. With this screw out. Yeah. We are in. Haha. This one has been repaired a few times. Oh, look at that. So it's completely different. So there's a funny... Oh, what the heck is that? This we need to remove. Some crap. But look at this. I need to get some better light. I found out something more interesting here. See? This whole unit, if you push it real careful, you can see that the whole coil is moving in the wrong direction. See? So this is called a needle bearing, and the center rotating shaft is actually a needle going in here, and this is loose because this one is not correctly adjusted or something. So how is this made? I think we need to take off this piece so I can show you this, the way that the other needle or the other indicator is going down here to the other meter. It is just nearly impossible to get light down there and get it in focus. But the other meter is down there. Damn it, it's impossible. Yeah, I think you can see it now. So that is how it works. This is amazing. And the two needles. See, down here. Actually, a lot deeper. Yeah, now I got it. This is how deep it is. Wow. This is the magnet. This is really old tech. Huh.